Today we're going to talk about the characteristics of quadratic graphs. Some of this will look very familiar from the previous lessons. Number one is a standard form equation, meaning that it's an ax squared plus bx plus c form. When we have a standard form function, we can use the axis of symmetry to help us find the vertex. The equation for axis of symmetry is x equals negative b over 2a. If I do negative b, I'll be taking negative 5, which makes that a positive 5, over 2 times a, and a is 1. So 2 times 1 is 2. It's okay to leave this fraction as your final answer. To graph an improper fraction, you'll want to think of it as a mixed number instead. So x equals 5/2 is at 2.5. Just like before, we'll graph our axis of symmetry using a dotted line. The axis of symmetry cuts our parabola into 2 equal parts. The vertex and the axis of symmetry share the same x value, so I can go ahead and write that down. To find the y value of the vertex, I'll take my x and plug it in for each of the x's in the original function. You may want to pull out your calculator to do this, since it is a fraction. Remember, use parentheses everywhere that you're going to plug the 5/2 into the equation. To enter a fraction in your calculator, you can do alpha y equals enter. Remember to close your parentheses and square it in that first term. Then you'll do negative 5 parentheses, and we'll enter the 5/2 again. And then plus 4. That gives us an answer of negative 9/4. Again, when it comes to graphing, you may want to think of that as a mixed number instead of improper. So negative 2 1/4. So the vertex always lies on the axis of symmetry at 5/2, negative 2 1/4. So about here. Now that we have that, we'll find our y-intercept. Remember, the y-intercept tells us when the graph crosses the y-axis, and we know that it crosses the y-axis when x is 0. So we will take a 0 and plug a 0 in everywhere that we see x in the original function. That's going to cancel out the first term and the second term, and the only thing that will remain is the constant, 4. So that's what y is equal to. And now we'll put that on our graph, 0, 4. We know that the axis of symmetry divides our parabola into 2 equal parts. So if we have a point on one side of the axis of symmetry, we will have the mirror image point on the other side. And now we can go ahead and sketch our graph. The rest of these lines deal with new concepts for us. We haven't done x-intercept before, but I bet you can make a prediction of what we're going to be looking for. If the y-intercept tells us where the graph crosses the y-axis, then the x-intercept will tell us where it crosses the x-axis. Now, you may not have known this, but you have been finding the x-intercepts over the last couple weeks. Every time that we solve a quadratic function, whether we're factoring to solve or using quadratic equations or taking square roots, all of those are giving us the x-intercepts, the solutions to the function. So one of the ways that you can find the x-intercept is you could actually factor this function. This particular function factors into 2 parentheses, x minus 1 and x minus 4. When I solve each of these, I get x is equal to 1 and x is equal to 4. Now, I could have looked at my graph here and kind of made a guess, but we don't want to just guess. We want to be precise. This is precise, and it tells us that the graph does cross at 1 and does cross at 4. We'll write these as points. When x is 1, y is 0, and when x is 4, y is 0. Now, I want to show you on your graph also, on your graphing calculator. If you open it up and you go to your y equals and you put your equation in, x squared minus 5x plus 4, and you graph this, as long as you are using your graph table mode, you can see that it does indeed cross at 1, 0, and 4, 0. These are not only solutions for x, but we also call them the zeros of the function. Anytime the graph crosses the x-axis, y is equal to 0. So you can use your table to confirm this. All right, now we're going to talk about the maximum and minimum. The maximum is the highest point that the graph goes to, or the minimum is the lowest point that the graph goes to. A parabola only has one or the other. It will be found at the vertex. This particular parabola has a minimum. Now, when you write your minimum, we're only going to use the y value, because anytime we talk about up or down, we're talking about the y-axis values. So the minimum for this graph is at y equals, and it's going to be the y of the vertex, so negative 9/4. All right, domain and range. Domain only focuses on my x values, and range focuses on my y values. One of the things that I tell students to remember when it comes to domain, we're going to write both of these in interval notation. And the way that we're going to write them, the x values tell me left to right. Now, don't forget, your axis continues infinitely in each direction. So I often will tell my students to add the negative infinity and positive infinity to this axis. So you're going to ask yourself, how far to the left and how far to the right does this graph go? Now, when you look at it, you might not realize that it is continuing left. But if you look at the slant of this line, not only is it going up, it is going up and left, and it's going up and left forever. So it is going infinitely to the left. So we'll write down negative infinity. Same thing on the right-hand side. It is going up and right forever. So how far right? Positive infinity. In interval notation, you have to choose between a parentheses or a bracket. Infinity always gets parentheses because it continues on forever. It does not stop. Range is going to talk about your y values. And the way that you write your range is to always look at the lowest y value and then the highest y value. So the lowest y value will also be found at the vertex. The lowest y value for this graph is negative 9/4. It stops at that value, and therefore you're going to put a bracket. This graph does not go below there. As far as the highest y value that this goes to, since it has arrows on the end of the graph, it tells me it continues on infinitely, and it's headed to positive infinity. So that's what I'm going to write down. And that has a parentheses. All right, increasing and decreasing. Increasing and decreasing are going to use the x values to write an interval. Now, these particular intervals are always going to be parentheses because we don't have a definite stopping point. So when I explain this in class, usually I will tell students to take their finger and start on the left side of the graph and literally trace down the graph or up the graph to see what is happening. If they see that they are going down, they are decreasing. So I'm starting here on the left, I'm going down, down, down till I get to here, and then it changes. And on this side, I'm going up. So this side is increasing. So like I said, we're going to focus on these x values. I am decreasing from negative infinity all the way till I get to the axis of symmetry. And the axis of symmetry sits at 5/2. So that's where I stop decreasing. And then from 5/2 all the way to infinity, I'm increasing. So when you write these, make sure that you write them on the correct line. So increasing is going from 5/2 to infinity. We'll use parentheses on both. And decreasing is from negative infinity to 5/2. Always write your intervals from left to right, left to right. Okay, these last two lines deal with end behavior. And the end behavior is literally looking at what the graph is doing on each end. So the way that you would read this is as x is approaching negative infinity. That's telling me to focus on the left side of the graph. What is the graph actually doing? Where is y heading? Well, with parabolas, you're only going to have one of two answers. Either it is heading to positive infinity or it's heading to negative infinity. So on the left side of the graph, we're headed to positive infinity. This one says that when x is approaching positive infinity, that would be the right side of the graph. What is y doing? Well, on the right side, I'm also approaching positive infinity. With all parabolas, you'll notice that these two answers are going to be the same because both ends are either headed up or both ends are headed down. All right, let's look at number 2, and we're going to use our graphing calculator and talk about ways to look at the table to get answers. All right, in number 2, we're going to go ahead and get out our graphing calculator and we're going to graph this equation. If you have anything currently entered into your graphing calculator, let's clear it out now. So we have negative. Make sure that you use the negative at the bottom of the calculator. And I need to put a fraction in. So alpha, y equals, enter, 1 divided by 3. X squared, and then minus 5. All right, we'll go ahead and graph it, and we're going to look at our table. One of the things that I would tell you to look for is a pattern. Right now, when I'm looking at the table, I don't really see a pattern. I could probably make a prediction of where my vertex is. 0, -5 is a pretty good prediction, but let's verify by looking at the table altogether. The way that you use the table is to do second graph. Then you can use your up and down arrows to move. And you'll notice that as you move up and down the graph, this cursor will move on the actual graph, showing you where these points are located. Now, when you look over here at the table, what's really neat about this is you can see this pattern occurring. These pairs, -16/3, -16/3, -19/3, -19/3. These are the pairs of points that there are the mirror image points on each side of the parabola. Notice the only one that doesn't have a pair, 0, -5. So this is indeed my vertex. We'll go ahead and write that down. Now, if you have the vertex, you have the axis of symmetry. We mentioned earlier that they have something in common. The x value of the vertex is the axis of symmetry, x equals 0. That means that this axis of symmetry is actually the y-axis. I'm going to go ahead and graph my vertex, 0, -5. Now the y-intercept occurs when we plug a 0 in for x. It's when the graph crosses the y-axis. Well, in this particular case, the y-intercept and the vertex are exactly the same point. Now let's pull our graph back up. Does this graph cross the x-axis? No. So in this particular case, I do not have an x-intercept. All right, looking at the graph again, will this graph have a maximum or a minimum? It can only have one or the other. This one has a maximum because the vertex sits at the top of the parabola. Now remember, when you write your maximum, it is y equals, and it's going to be y equal to the y value in the vertex. So my maximum is at y equals -5. Now I'm going to go ahead and sketch the graph so I can look at this and identify these other parts. The domain and the range. The domain only focuses on the x values. How far to the left and how far to the right does this graph go? With parabolas, the domain is always the same. -infinity to +infinity. Range. The range focuses on my y values, my y-axis. How low and how high does this graph go? Well, since the arrows point down, this graph goes infinitely low. So how high? What is the highest y value that it goes to? -5. -5 gets a bracket because the graph stops there, but infinity gets parentheses because it continues on. All right, so now it's time to talk about increasing and decreasing. Remember that when we do increasing and decreasing, we have to use the values on the x-axis. And we are going to use -infinity, and we're going to use +infinity. And the axis of symmetry tells us the center point. So these will be the 3 values I focus on. So on the left side of the graph, I'm going to start tracing the graph, and it goes up, which means it is increasing in this interval. And on this side, it is going down, so I am decreasing in this interval. So increasing between -infinity and 0, decreasing between 0 and +infinity. Now the last part, my end behavior. Remember, on parabolas, this is always the same. Where are the ends of this graph going? Both ends are pointing downward. Both ends are headed to -infinity. So now let's look at number 3, our final example. This is an example of a function that is written in vertex form. Remember, when I'm identifying the vertex, I use the h and the k. The h always changes signs, but the k will remain the same. So the vertex is -3, +1. Now that I have my vertex, I also have my axis of symmetry. X is equal to -3. Let's go ahead and put these two things on our graph. Now I already know that this graph is going to open downward because there is a -a term. My y-intercept will be below my vertex. To find my y-intercept, I can put a 0 in where the x is. When I do that, 0 plus 3 is 3. I'll square that and get 9. Then I put my negative on there, -9, and then I add 1. So I get -8. I'll put this on my graph. Now remember, the axis of symmetry is my center line. So since this point is 3 units away from center, I can go 3 units to the left, and I know there will be a point here also. Now it's time to find my x-intercept. I know I have an x-intercept. I have 2 of them. So I have an option. I can solve this equation or I can look at the graph. And I'm going to pull out my graphing calculator and do this now. Let's clear out the previous equation and enter negative parentheses x plus 3, close the parentheses and square it, plus 1. Now remember, you can look at your table to see where it is crossing. To use the table, do second graph, and you can move up and down. Wherever I see that y is equal to 0, that is where it intercepts the x-axis. So at -4 and -2. And remember to write these as points. So -4, 0 and -2, 0. Does this graph have a maximum or a minimum? It has a maximum. And remember, we write the maximum as y equals to the highest y value of this graph. So y equals 1. It's also the same as the vertex. Domain. How far left and how far right does this graph go? Infinitely left and infinitely right. Range. How low and how high. The lowest that this graph can go is -infinity, and the highest y value that it goes to is 1. Put a bracket on the one side because it stops there. Increasing versus decreasing. Remember, only use the x values to describe increase and decrease. Always put your -infinity and your +infinity on your number line, and then circle your axis of symmetry number. These will be your intervals. So on the left-hand side, I am going up, so I'm increasing, and then I am decreasing on the right-hand side. So I am increasing between -infinity and -3, and decreasing between -3 and +infinity. Here's my final. Where are the ends of this graph going? Both of them are going down, so both of them are approaching -infinity.